A woman stands in the cereal aisle. Her heart slams against her ribs. The fluorescent lights are just lights, the shopping cart just a cart, but her body doesn't believe it. Her throat tightens, hands go cold. She's not in danger. She knows that, but a song playing over the store speakers, a tone of voice from a stranger, something flipped a switch deep in her brain. And now her whole body is bracing for impact. Trauma doesn't live in the story you tell. It lives in the physical imprint left on your nervous system. Bessel van der Kolk, a psychiatrist who has studied trauma for over 4 decades, put it bluntly: the body keeps the score. But his deeper insight is about how the brain itself gets rewired. Not metaphorically, structurally. Think of your brain as having a smoke detector and a watchtower. The amygdala is the smoke detector. Its job is to scream, fire, the instant it senses danger. And after trauma, it becomes hypersensitive. It screams at the smell of toast burning when the house burned down years ago. It doesn't care about time. It only knows the alarm. Normally, the prefrontal cortex, the watchtower, looks down, sees the toast, and says, "Stand down." It's just breakfast. It calms the amygdala, but trauma damages that connection. The watchtower goes offline, or its voice becomes a whisper. So the smoke detector keeps shrieking. You stay in fight or flight, even when you're perfectly safe. Most memories fade into a coherent story. You can narrate your first day of school. Who was there? What happened? Traumatic memories don't do that. They fragment. They get stored as isolated sensory impressions. The pressure on your chest, a specific smell, the vibration of a floor. These fragments aren't filed as past. They sit in your brain as living, present moment physical experiences. Your body reacts to them as if the event is happening right now. That's the tyranny of the past. It's not a bad memory that bothers you from time to time. It's a full body takeover. You're not remembering the car crash. Your shoulders are bracing for impact again. You're not thinking about the assault. Your stomach is dropping as if the floor just gave way. The event is over, but your brain never got the message. The problem is a brain that can't tell then from now. Teaching it requires more than just words. That discovery led van der Kolk to some surprising places, and a fundamental truth. Talking about what happened isn't enough to reach the parts that hold the terror. To rewire that alarm system, you have to go deeper. A man sits in a leather therapy chair, describing the night his motorcycle went sideways. He remembers the headlights spinning, the pavement rushing up. The therapist nods, invites him to keep going. But something in the room is failing. Because as he speaks, his body is still on the asphalt. His shoulders hunch. His breath goes shallow. Words pour out, but they don't touch the cold sweat on his palms. Bessel van der Kolk watched this paradox in a brain scanner. He asked trauma survivors to recall their worst memories while an fMRI machine tracked blood flow. What the scans showed appended decades of clinical practice. When the memories hit Broca's area, the speech production center of the left frontal lobe went dark. Not dimmed, not sluggish, online to offline in seconds. Broca's area is the part of your brain that turns raw experience into sentences. Without it, you're locked out of language. You can feel the fear, the tight chest, the urge to run. But you can't tell anyone about it. You can't even tell yourself. The very tool talk therapy relies on, putting feelings into words, gets physically yanked offline by the trauma response itself. This isn't a metaphor. Van der Kolk's team watched it happen. Blood flow to Broca's area plummeted while the brain's subcortical threat system flared up. The amygdala, an almond-shaped alarm in the deep brain, screamed danger. And the prefrontal cortex, the rational part that says you're safe now, went quiet too. The logic center and the speech center both get benched at the exact moment you need them most. That's why rational insight can't heal a subcortical threat response. You can't talk your amygdala into chilling out. You can't reason with a smoke detector when it's already shrieking. The therapy session becomes a cruel mismatch. The patient sits in a calm room, recounting horrors, while their nervous system acts as if the assault, the crash, the explosion is happening right this second. The therapist offers insight. The body offers adrenaline. When you're trapped in a fight or flight survival loop, the prefrontal cortex is not in charge. The older, faster limbic system runs the show. It doesn't process language. It processes sensation, heat, motion, pressure, sound. The body re-experiences the event through raw sensory fragments, not words. So asking someone to talk through it is like asking them to explain a fire while they're burning. The therapist's office runs out of tools because the problem never lived in the frontal lobes to begin with. Trauma doesn't store itself as a coherent narrative. It stores as a series of trigger responses, a body memory that has no timestamp. Until something else reaches that somatic alarm, words remain little more than noise. The question that now presses against every therapy session isn't how to understand the past. It's how to reset a nervous system that keeps living in it. Van der Kolk watched the monitors as a woman relived a car crash. Numbers ticked. The colored maps of her brain shifted. In seconds, the prefrontal cortex, the seat of rational thought, dimmed to a cold blue. Glucose uptake in those regions plunged nearly 20%. The drop is not subtle. Your prefrontal cortex burns energy just to keep the amygdala in check. When it starves, the watchdog breaks its leash. Simultaneously, the amygdala and hippocampus flared bright red. Oxygen and glucose flooded the threat detection circuit. Without a working prefrontal cortex, you lose the ability to tell past from present. The flashback isn't a memory. It's a reliving. The scanner shows why talk alone fails. The part of the brain that needs to form a coherent story has literally gone offline. The scanner doesn't lie. When memories hijack the brain, reason gets evicted. So how do you treat a wound you can't even look at straight? A ballet dancer stands perfectly still in the studio mirror. Her shoulders curl forward like she's bracing for impact. The instructor keeps correcting her posture, but within minutes, she's hunched again. This isn't a choice. Trauma writes itself into the body's script long after the curtain falls. Van der Kolk noticed something strange in his patients. Their bodies kept replaying the trauma even when their minds didn't. A rape survivor flinched at every touch. A veteran hit the deck when a car backfired. The body remembers what the mind tries to forget. Chronic pain often follows this pattern. Scans show that trauma survivors have overactive pain receptors. A light touch registers as a threat. The nervous system gets stuck in a feedback loop, amplifying signals that should be routine. It's not in your head, it's in your cells. Depersonalization makes this worse. When the body becomes a war zone, some brains check out. They mute physical sensations entirely. Patients describe watching their hands move like they're puppets. The price of numbness is losing your anchor to the present. But here's the twist. The body can also lead you back. Trauma survivors who regain interoceptive awareness, the ability to feel their heartbeat, their breath, recover faster. The stage directions can be rewritten. But how do you rehearse a new role when the old script keeps running? The electrodes trace faint lines across her scalp as she stares at the screen. A simple game. A spaceship drifting through a field of stars. She doesn't move a joystick, doesn't press a button. The ship rises when her brain quiets the overactive fear circuits. Falls when the alarm spikes again. She's not thinking her way out of anything. Her brain is learning to recalibrate its own threat detector. Neurofeedback works beneath language. You sit there watching your brain's electrical patterns in real time, and the system rewards you when the amygdala's frantic waves settle into a steadier rhythm. Van der Kolk's patients came in with hair-trigger stress responses. Their brains screamed danger at every minor provocation. After 20 sessions, those brains looked different on the scans. The salience network stopped treating a slamming door like an incoming mortar. The key is timing. The reward hits exactly when the brain moves toward regulation, not a second later. That precision matters because the autonomic nervous system learns through immediate feedback, not through insight. You can't talk your heart rate down from 120 to 80. You can't argue with your sweating palms. But you can show the brain a better pattern and let it copy itself. EMDR takes a stranger path. A therapist moves 2 fingers back and forth in front of your eyes while you hold a traumatic memory. Side to side, like watching a metronome. The bilateral stimulation seems to unlock something stuck. Patients describe the memory losing its charge. The image remains but the terror drains out. Researchers found that the eye movements dampen activity in the amygdala and boost connectivity to the prefrontal cortex. The brain finally files the memory as past, not present. Both techniques bypass the storyteller. No one asks you to reframe your narrative. No one suggests you think differently. The body learns first. The salience network recalibrates its threshold for threat, and only then does the linguistic brain get the message. The alarm stops ringing for shadows. But once the alarm quiets, what story does the mind tell itself now? The choir director raises her hands and 60 people breathe in at once. Not thinking about it, not deciding to synchronize, their bodies just do it. A collective inhale that sweeps through the room before the first note even sounds. Something ancient switches on in that half-second pause. Stephen Porges called it the ventral vagal complex, the newest branch of our parasympathetic nervous system. Mammals evolved it to do one thing: connect without fear. When this system activates, your heart rate drops just enough. The muscles around your eyes relax. Your middle ear tunes itself to the frequency of human voices. You stop scanning for threats and start reading faces. Porges mapped the vagus nerve like an electrical grid with 3 circuits. The dorsal vagal circuit is the oldest, the one that makes a lizard freeze when grabbed. The sympathetic fight or flight system fires up next, dumping adrenaline into your bloodstream. But the ventral vagal circuit, that's the social safety switch, and it only comes online when another nervous system signals that you're not alone. Trauma locks people into the first two circuits. Your brain starts treating every interaction like a potential ambush. The ventral system won't engage unless the body receives a clear signal. You're with someone, and that someone isn't a threat. Synchronized activities deliver that signal through muscle, breath, and rhythm. A theater troupe moving through the same blocking over and over. A rowing crew pulling oars in perfect time. A choir blending vowel shapes until the boundaries between voices dissolve. Van der Kolk's team watched what happened when traumatized patients joined these groups. Their heart rate variability shifted within minutes. The sympathetic spike that usually accompanied social proximity, it faded. The brain's default mode network, the circuitry responsible for knowing who you are in relation to others, started lighting up again on fMRI scans. That network goes dark during trauma. Restoring it isn't about talking through the past. It's about giving the brain repeated, physical proof that connection can feel safe. The ventral vagal complex doesn't just calm you down. It changes what you perceive. When it's active, you see facial expressions more accurately, hear vocal tone with more nuance, interpret neutral gestures as neutral instead of hostile. A person whose threat detector is stuck in overdrive misreads the world constantly. Synchronized movement forces a correction. Your body entrains to the group's rhythm, and that entrainment tells the ancient fear centers, stand down. No amount of cognitive restructuring achieves this. You can't think your way into a felt sense of safety. You have to borrow it from other people's nervous systems until yours remembers how to generate it on its own. But borrowing safety requires other people willing to lend it, and that changes the whole frame of recovery. A woman sits at her kitchen table, staring at a blank page. For years, she couldn't write about the accident without her hands shaking. Today, she picks up the pen. The words come slow at first, then faster. She writes about the screech of tires, the crunch of metal, the smell of burnt rubber. But this time, something's different. Her heart stays steady. Her breath stays calm. She's not reliving it, she's remembering it. Bessel van der Kolk found that trauma lodges itself in the brain as fragments. Images without context. Sounds without sequence. The hippocampus, which normally organizes memories into chronological order, gets overwhelmed. That's why flashbacks feel so vivid and disjointed. They're raw sensory data that never got filed properly. When the body finally feels safe, the brain can start sorting. It's like cleaning out a cluttered attic. You take each piece out, examine it, and decide where it belongs. The traumatic memory doesn't disappear, but it gets integrated into the larger story of your life. You realize it's one chapter, not the whole book. This process explains why trauma therapy often involves storytelling. Whether it's writing, talking, or art, the act of creating a narrative helps the brain reorganize the memory. You're not changing what happened. You're changing how your brain processes it. The event moves from the present tense to the past tense. But here's the catch. This only works when the nervous system feels secure. If the body's still stuck in fight or flight mode, the brain won't risk reopening that file. That's why safety comes first. Once the body learns it can relax, the mind can finally do its job. So what happens when the narrative shifts? The brain stops treating the trauma as an ongoing threat. It updates its predictions about the world. You might still feel sad or angry about what happened, but you stop expecting it to happen again. The trauma becomes history, not prophecy. Yet this raises a question. If rewriting the narrative is so powerful, why do we often resist it? What keeps us clinging to the old story, even when it hurts?